take a look through Monday's homework. So you had questions 1 and 2 about lines of symmetry. So we've got a shape here, and we can see that there's a line down the center which does divide this into 2 mirror images. So that's the line of symmetry. And they asked us to name the line of symmetry. Now you remember, we can name a line by any 2 points that are on the line. So there's a few different options to this. I'd probably go for the points, the 2 furthest apart points. They're not endpoints, so I could call it AX or AD or AP or DP, etc., etc. So any 2 points on the line will name that line, and that is the line of symmetry there, going down the center of the shape and dividing it in a mirror image. Now, next they asked us to measure the following distances, and they've given us an example. So A to B is 2 units, it's 2 boxes across. A to C, similarly, is also 2 units, 2 boxes across. So they've asked us to find out what D to E is. So D to E is 1, 2, 3 boxes across. So 3 units. We don't know what those units are. We can't call them centimeters or millimeters. They're just boxes. They're just units. D to F, the mirror image, is also 3 units. P to Q, 1 box, 1 unit. And its mirror image, P to R, is also 1 unit. Finally, X to Y is 2 units, and X to Z is 2 units. And what do we notice? The distance is the same on either side of the axis or line of symmetry. Now, taking up all the space there with that answer. And finally, part C, I'll write the answer to part C down here. Describe in your own words what a line of symmetry is. So again, in your own words, the definition maybe from your notes would have been what you used. So a line that divides a shape into 2 identical mirror images of each other is how I would describe it. And you may have written that a bit differently. If you're not sure about your explanation and you want to double check with me, just send me an email or comment on today's Google Classroom and I'll let you know if your answer is okay. Into 2 mirror images of each other. And that will be a perfectly fine explanation of the line of symmetry. Now, question 2. For each of these shapes, draw in all the axes of symmetry that you possibly can, and some shapes mightn't even have an axis of symmetry. So we might just note that if there is no axis of symmetry, no line where you can fold it and it will be a mirror image. Any axis of symmetry that exists will have to go through the center of the shape. So if I look here, if I draw a line straight up and down through the center of this shape, it doesn't have to be exact in terms of what we're doing here. We've just got one axis of symmetry. Is there any other line that we could fold this on and we'd have a mirror image? And we can just check through rotating our ruler around, are there any other lines that will do this for us? And we can see there isn't. So there's just the one axis of symmetry for that first shape. Now, an isosceles triangle, we had this already in our notes, and we know that this just has the one axis of symmetry with our identical right-angled triangles either side. Does this shape have an axis of symmetry? If it did, maybe it would be along here. If it did, it must go through the center, right? The center is roughly here. We can see now if we try and do a diagonal line, it's close, but no. If I could do a line through there, no, no. So I can kind of try it and see that there's no line that I can draw through the center of this shape, which will make 2 mirror images. So we can write down that this has no axis of symmetry. It's not a symmetrical shape. An equilateral triangle we also did in our notes, so we know that there are 3 axes of symmetry for this shape. Through the center of the triangle and through each of the 3 vertices, making a right angle with the opposite side, the side opposite the vertex. And again, we're just drawing it in as a sketch, so you don't have to be 100% accurate with this. We have 3 axes of symmetry, just as we'd noted in our notes copy. Now, a square. I mentioned this already, didn't I? So, every square is also a rectangle, and we know that rectangles have 2 axes of symmetry. So we know that we'll have an axis of symmetry down here, and we'll have one going across here. I'll go over with the ruler in a second. But I mentioned that squares, unlike rectangles, can be folded along the diagonal as well. Because when I do that, the corners here, if I bend this over the diagonal, the corners here will line up exactly. I'll get an exact mirror image, which means I can go through this diagonal as well. And I have 1, 2, 3, 4 axes of symmetry. So 4 axes of symmetry for a square. Are there any more? Any more that I've missed out? There's no other lines that can go through that center point. If I tried to draw one through here, that's not going to divide it into 2 mirror images. So those are my only axes of symmetry. This is a scalene triangle, and we know, because we can just learn this off, that this has no axes of symmetry. We saw that yesterday when we were learning about axes of symmetry. Scalene triangles don't have an axis of symmetry. And the next shapes here, okay, a kite. So if it has an axis of symmetry, the equal length sides must be across from each other. Here's my center. So my axis of symmetry is going to go through the center and divide this into my 2 mirror images. What about if I try to draw one down here? I think you can see that's not going to fold over in a mirror image. So this just has 1 axis of symmetry. A parallelogram. Now, if it has an axis of symmetry, it must go through the center, and it must be a line that divides this up so that it's a mirror image. And I'd say some people got stuck on this one. If I do a line straight down, we can see that that won't fold over. But what if I do a line that's parallel to the sides? Didn't draw this very well. If I do a line parallel to the sides, then if I fold these over, I will have a mirror image. Similar thing happens if I do the line going this way, and again, it's parallel to the other 2 sides. So this actually does have 2 axes of symmetry. I should have 2 M's there, sorry, bad spelling. Luckily they don't penalise you for spelling in maths. Would I be able to fold this? No, they're not going to join together, okay, so I won't have a mirror image. What about this shape here? 1, 2, 3, 4, 5, 6. It's a hexagon, 6 sides. So a hexagon does indeed have an axis of symmetry joining any 2 of the straight edges to each other. That will go through the center. 1, 2, 3. What about if I joined, let me just do this in a different color to make it clearer. What about if I joined the opposite vertices to each other? That also makes a mirror image. Hexagons are very symmetrical, which is why they keep turning up in chemistry. You'll learn that if you do chemistry for Leaving Cert. A lot of symmetries in some of the chemical compounds, the shapes that the compounds take. So 1, 2, 3, 4, 5, 6 axes of symmetry for a hexagon. Maybe a bit surprising. So a hexagon has 6 equal sides and 6 axes of symmetry. Okay, my semicircle, again, if it has an axis of symmetry, it's going to go through the center of the shape. And we definitely do have one here through the halfway point. That will give me a mirror image, but there's no other line that I can draw through the center that's going to cut that into mirror images. So this just has one axis of symmetry. This is what's called a rhombus. So a rhombus is a parallelogram where all 4 sides are the same length. So because it's a parallelogram, what we did to the parallelogram before can be done again. So I can do the line parallel to that side and the line parallel to this side. Okay, so what about joining the vertices? Now we couldn't do it with this parallelogram, which is like a rectangular parallelogram, but a rhombus is a square parallelogram. Actually, they're not always parallel. It's just that all sides are equal. So we actually have another 2 axes of symmetry, just like we have with our square, going through the vertices as well. So a rhombus has 4 axes of symmetry. And finally, we have a 1, 2, 3, 4, 5, a pentagon. A regular pentagon, all the sides are the same length. So what about if I join the vertex to the side opposite it? So we know that any axis of symmetry has to go through the center. That's definitely a mirror image, right? And so if I can do it for one vertex and edge, I can do it for the other vertices and edges as well. So 1, 2, 3 axes of symmetry, and I hope you can see it's always a vertex and an edge with a pentagon, that there are no other axes of symmetry there. So 3 axes of symmetry for my pentagon. If I tried to draw any other line through that center point, it's not going to make a mirror image on both sides. Okay, so today we're not going to move on to any new notes, but I want you to do a little bit more practice with axes of symmetry. And this time you're going to be given half the shape and asked to draw it in. So be a bit time consuming. Do as much as you can in about 20 to 30 minutes and then you can stop. But part of maths as well is about getting quick and efficient with these types of things too. So just remember, it doesn't have to be perfect. You're just trying to get the concept of equal shapes. So don't spend ages and ages drawing, just do your best with it. Okay, thank you.